We're working more with understanding exponential functions. And we have to understand all parts of the exponential function so that we can look at it and analyze it very quickly. So our first example is the exponential function f of x equals 8 times 2 to the x. Well, obviously we need to know that it's exponential, and there's something very easy that gives that away. That's right. There's an exponent in it. And it's raised to an unknown exponent. That's what makes it an exponential problem. Kind of obvious. All right, so when we look at this, we should be able to rattle off a couple of things right away. Before we even look at a graph or even decide to start answering it, we need to ask ourselves, is this a decay or growth problem? That means we look at the base. So we take our little beady eyes and we look at the base. All about that base, no problem. Yep, don't make me sing, I will. And it is all about that base, and that base happens to be 2. So this is a growth. Because remember, if it's between 0 and 1, then it's decay. The next thing that we should be able to figure out very quickly is the y-intercept. Where is this going to cross the y-axis? Well, the answer is 8. Do you understand why? Well, let's make ourselves a quick little chart right here. Actually, a quick little graph. There it is. Now, we understand that if we are on the y-intercept, that means we're somewhere on the y-axis. And everything on the y-axis means that the x value is 0. So if I put 0 into this equation very quickly, 8 times 2 to the 0 power, well, we have to do exponents first according to PEMDAS, so that's 1. 8 times 1 is 8. And that's how I picked out 8 very quickly. No, not because I put a 0 in and did into my head quickly. We know that the a value will always give us the y-intercept. And if you're saying, what a value are you talking about? I'm going back to the general form of every exponential function. A times b to the x. Now I got another question for you. What's the x-intercept? Aha, you're right. There is no x-intercept because according to the general form that we have right here, this is never going to touch the x-axis. Remember, that's its asymptote. Now, you can get an exponential function to cross an x-axis, but that's when we're getting into translating graphs, shifting them up or down. As of right now, we're doing no shifting. We are simply looking at a basic exponential function. So the x-intercept, there is none. It is not going to cross the x-axis. I'm actually going to come down here and I'm going to say, let's do E first. Can we sketch a graph of this quickly? All right, let me clean this up over here. So first of all, we know that it's growth. So in our minds, here we are, we're happy because we're doing math. And then we have our minds, and our little hamster has our energy on our wheel. And since it is growth, you know that it's going to be going up. So basically, I have to have some kind of line that's growing. And then right here, we can label this point. We know that our y-intercept is when x is 0, y is 8. And there it is. That's our graph very quickly. Remember, I didn't say be precise about it. I said do it quickly. So quickly you should understand that it is a growth. And you should understand the y-intercept is always the a value. And you should understand that the x-intercept doesn't exist. It's an asymptote. So therefore, it's never going to cross the x-axis. So there is a rough sketch of our graph. Now I'm going to go back to D. and I want to look at the change over two different time intervals, I want to look at the slope a little closer. So give me 2 seconds and let me clean all this up. Well, I'm going to get out my graphing calculator, and I'm going to type this in. Times 2 to the x. Now, my window, I'm going to set up my window. I know I'm not going to go below the x-axis. So that's why my y starts at 0. I'm going to a high of 50, and my y scale is moving by 2. I've also shrunk my x a little bit to go from -5 to 5. So when I graph it, I will still see my entire line. I just don't need to see below 0 because it doesn't go there. So now I'm going to take this and I'm going to drag it out, put it on the screen here. Let me adjust it a little bit. And they said they wanted me to look at the slope over two intervals, from -1 to 0 and 0 to 2. So now we've got to pull out of our heads, what does that slope mean again? Slope means the change in y over the change in x. Well, the x's they want me to put in are -1, and then they want me to put in 0 and get my corresponding y values. Well, we know this one already. When we put a 0 in, we already figured out that that is the y-intercept. So the y-intercept was 8. How about when I put a -1 in? Well, if I do a little 8 times 2 to the -1. All right, have to do our exponents first, and we know anytime we raise to a negative, it flips. So that's 8 times a half, so it's 4. So when I put -1 in, my resulting answer is 4. Now I can finally do the slope on that. The slope tells me to take my y values and subtract them, and I'm opting to subtract this way. So be careful. 0 minus a -1. So that's 4 over 1. So my slope in this first interval is 4. I'm going to do the same for my second interval. So I have to figure out, scroll down a little bit, when I put in a 0 and a 2 now. Well, once again, putting in that 0 is not hard at all. When I put a 0 in, I know I get 8. When I put a 2 in for x, take a second here, 8 times 2 to the second, 8 times 4, it's 32. All right, so when I put a 2 in, I get 32. Now I have to do the slope. I'm going to, once again, choose to subtract in this direction. So 32, take away 8, that's how my y's are changing, compared to my x's changing, 2 minus 0. That's 24 over 2. My answer is 12. My slopes are different. At one point I have a slope of 4. At another point I have a slope of 12. I have different slopes, as I should, because slopes are constant with linear lines. This is very important, people. I think you should be taking the hints by now. This is not a line. This is a curve. Now, we're pushing slope down your throat because it's very huge in calculus. And let me show you a little bit about what calculus is all about. If I wanted to look at the interval between -1, let me use the right colors here. If I wanted to look at the interval between 0 and 2, that's what I did down in purple here, and I'm going to draw a line from 0 to 2. A slope would be a straight line that touches the curve just once. So something that would touch the curve just once would look like that. See, I'm going from 2 to 0, and I'm trying to get a line that's, here's a new word you're going to learn later on, tangent. It just touches the line once. There we go. That's what my slope looks like from 0 to 2, because I did that in purple. Now, let me get the slope that goes from -1 to 0. I'm going to do that one in a pink line. All right, from 0 to -1, if I drew my line, and it touched just once, now I know, there we go, like that. This one has arrowheads because I'm just trying to show you something. Look at the difference in the slopes. Think about skiing. Which one would you rather ski on? Well, you know me, guys, I'd rather ski on this one. It's steeper. And look, that's the slope with the higher number. This one's more of like the bunny slope, and look how that. So yes, in this exponential curve, our slopes change and get steeper because we are accelerating and getting steeper very quickly because our base is doubling every time. All right, one more. We're going to look at this last one, and it's an exponential function. And let's see if we can go through this really quickly. Is it decay or growth? Bam, it's decay. What gives it away? I look at the base. The base is between 0 and 1. So this is decay. This means I'm being left with 2/3. That's really important. Most people don't understand that. I have 2/3 left over every single time. It means you're taking away 1/3, but you're leaving me with 2/3. I'm not taking away 2/3. This number tells you what is left over. We're going to do that a lot more as Unit 6 rolls on. What's the y-intercept? Oh, that's easy too. That's 6. All I have to do is look at the a value. What's the x-intercept? By now you should know me. I'm trying to trick you. That's right, you have to know all the tricks in math, and you just laugh at me and go, ha ha, that's amateur, Mrs. Trollin. I know there is no x-intercept. Can you sketch the graph of it quickly? All right, so can I sketch the graph of it quickly? Sure I can. I can come down here, whip off my x and y axis. Haha, Mrs. Trollin, I know that it crosses right here at the point 0, 6. And since it's decay, it means it's going to be going down. And since there is no x-intercept, it's going to get really, really close to the x-axis, but it's never going to touch it. Hey, how fast was that? You guys are getting to be pros at this. And the slope. Let's look at the slope real quickly again, and we're going to do it the calculus way. I'm going to come over here, and I'm going to get out our graphing calculator again so that we can look at the slope in terms of a tangent line. All right, give me a second. Here's our graphing calculator. Going to graph it. There's our graph. And let's get that slope. All right, let's make -1 to 0 again, the pink line. Come over here, get my pink line out. from -1 to 0. Tangent means to touch at one point. So I know it doesn't look like it, but that's really only touching at one point. So that's going to be what the slope looks like for there. And now let's get out, let's do green. From 1 to 2, wow, that's a different interval than the last one. So from 1 to 2, let's get out a green line. So from 1 to 2, if I were to draw a straight line, going from the interval 1 to 2, it would look like that. Kind of. There we go. Not letting me touch my line. All right. So what's happening there? Do our slopes look like they are consistent? No, it looks like the pink slope is steeper than the green slope. I can put them right next to each other and you can see, which trail would you rather ski down? You know me, the answer is always going to be the steeper one, so that's the pink. And that's because this slope is starting to flatten out because we're going down. So our slope will get closer and closer to 0. So what do I want you to learn today? Here's the summary. And this is very important. When you are looking at exponential and the b is between 0 and 1, we know it's decay. And we know that that letter A is the y-intercept. Beautiful. How about if we're looking at an exponential and the base is greater than 1? Then greater than 1, it's growth. And A is still the y-intercept.